Hey everyone, I'm a small lizard, and here's another question slash install minds video slash PnC content video, and I hope you guys do give it a shot. Pause the video, give it a shot, and I'll see you guys in about 2 seconds. Alright, let's begin. The test consists of 5 grade 1 questions A to E, 6 grade 2 questions F to K. The examiner plans to arrange all 11 questions in a random order regardless of grade, so we can jump out the questions together. Find the number of ways to arrange all 11 questions such that the last question is a grade 1 question. Alright, so we know that the last question must be a grade 1 question. So and there are 5 grade 1 questions in total. That means there are 5 possible questions to put at the last. Then we have the first 10 questions which we can arrange in anyhow. So 10 factorial, simply we have 10 factorial times 5, which will then give us 181, is it 2440? Never mind, let's just do it by hand. 181, yep, 44000 number of ways, right? 18,144,000 ways. Part B. Every grade 1 question must be separated from another with exactly one grade 2 question. So we can have this idea, grade 1, 1, 1, 1, 1. That's 5 of them. Realize that we only need 4 grade 2 questions. Then we have the remaining 2 questions, right, from grade 2. So we can be like this, it can be like this, it can also be 1 on each end. So a total of 3 possible cases, alright? But here's the thing, we can actually really look at it this way. We're gonna arrange these 5 grade 1 questions first with 5 factorial, arrange the 6 grade 2 questions with 6 factorial, and then the idea is that, you know, you're just arranging by like disregarding the other items. So it's as good as arranging each of them and then slotting both of them together like a hamburger. Alright, then of course we need times 3 because of the number of cases. We can have 2 at the extra 2 questions at the start or at the end, or 1 on each side for a total of 3 different cases. So very simple, 5 factorial times 6 factorial times 3, which would give us 5 factorial times 6 factorial times 3, that's 360 times 720, so 259,200 number of ways. Part 2. Now we are gonna split into 2 different sections, grade 1 followed by grade 2. So grade 1 will happen first, grade 2 will happen next. For the number of ways to arrange all 11 questions such that first question A is followed by question F. So because question A is in grade 1, question F is in grade 2, that means that in order for question F to follow question A must be the last question of grade 1, question F must be the first question of grade 2. In fact, it actually doesn't really matter because now we just need to consider, well, there's 4 questions left in grade 1, so 4 factorial. There's 5 more questions in grade 2, which is just simply 5 factorial. 4 factorial times 5 factorial is the same as 4 factorial square times 5. So 2880 ways. B. Slightly interesting. Questions B and K are separated by more than 7 questions. And now you realize that, hey, there's going to be more than one way for questions B and K to be separated by more than 7 questions. Because we can have 8 questions, we can have 9 questions, and 10 or more. But the thing is this, there are only 11 questions, and for question B and K to be separated by more than 7 questions, then we can only have 8 and 9 questions in between them, because questions B and K is already 2 questions. The maximum number of questions in between them is simply 9. Alright, so, well, again, question B is in grade 1, question K is in grade 2, so we need to kind of experiment a bit. Alright, now, if you think about it, let's look at the simplest case, or rather the minimum case where there are at least 8 questions between them. So B, 8 questions, and then K. Just realize there's 10 questions, alright? And you notice there's one more extra question. So it can either be here, or it can either be here, right? For a total of 2 cases. If B and K are separated by 9 questions, then you realize there's nothing else really. It's only one case, right? Because there's already a total of 11 cases. Alright, so this is where you need to take note, right? Compared to the previous video where there's only, let's say, one way to arrange the 2 children between the 2 parents, there's more than one way to arrange 8 questions between B and Likewise for part IB, you realize that there are 3 ways to alternate grade 1 questions with 1 grade 2 question. Alright? So what we need to do is, now don't forget, they are split into the grades. Alright? So, well, very simple. You notice that for, let's say, this first case right here, where there is 1 question in front of B, that means that B is the second question and K is the last question. Alright, so very simple. For the first case is 4 factorial times 5 factorial times 2. Alright. The idea is that there are 2 cases anyways. So we're going to arrange 4 factorial, the first 5 grade 1 questions, of course excluding B, so there's only 4 left. And then grade 2, there's only 5 remaining questions, so that's 5 factorial then times 2. Over here, 4 factorial times 5 factorial times 1, because there's only 1 way. So in total, we have 4 factorial times 3. So because there are 3 ways to obtain the following combination of question B and K being separated by more than 7 questions. Alright, so we have 24 times 3 times 5, which will then give us 360. Alright, so 4 factorial times 5 factorial times 3. Oh, whoops, I think I messed it up a bit. It's not 360, that's way too low. 8640. Yeah, it shouldn't be 360 because this is really 360 times 4 factorial should be more than that. Silly me. Anyways, yeah, so this is how we can actually think of like just arrangement when it's like you need to be careful of the context, especially in the case where they're gonna split the, in this case, the sections and therefore the questions that you need to arrange as well, or for part IB, where you don't have to really consider like what questions you want to slot inside. You can just think of it as arranging and then just automatically sandwiching them together. Alright, so there we have it, this particular example, and hopefully it is just as simple as you see it right now.